Welcome back in another video of a micro series. So today I want to focus on pooling equilibrium in insurance markets. So the plan is to look at this idea of a risk individual versus safe individual and then show to you that a pooling equilibrium cannot exist. Okay, so what do we know about risky and safe type, and how do we normally introduce the risky and the safe type? Well, it's a very common exercise to introduce the risky and the safe type by simply assigning them a different probability of loss. So the contract is the same. So this could be the lottery, if you like. So this would be the good state. I get more. This would be the bad state. I get less because I suffer some loss. But the probability of suffering that loss differs for the two individuals. So therefore, we would have an actuarially fair line, for example, that is steeper for the safe guy. Let's do it in green, and flatter for the risky guy. And let me do the 45-degree line to indicate um, the the full insurance. And let's change that to black. Okay, so this would be the actuarially fair lines, if you like. And then we're looking for a pooling equilibrium, meaning that the same package is offered to both individual, and no party, no agent involved has an incentive to unilaterally deviate. Well, because we're assuming free entry and exit in this market, for a pooling equilibrium to exist, it must necessarily mean that firms are earning zero profit. So same package, same insurance package, or insurance offer, if you like. Okay, let's call it P or package. Okay, because it's an equilibrium, it must mean that firms earn zero profits. If they earned profit, that means that there would be an incentive to enter into the market, and therefore it cannot be an equilibrium. So part of the requirement for an equilibrium is that firm earns zero profit. Therefore, I don't know where this P is yet, right? But if it is to be an equilibrium, it must be somewhere on the joint actuarially fair line. Now look at that line. If there's a lot of risky individual, it's going to be closer to the red line. If there's a lot of safe individuals, it's going to be closer to the green line. Let's say there's a 50-50 mix of them, right? So there will be some line P. There will be some line where um, any packages along those lines will at least satisfy that there is same insurance offered for everyone and firms earn zero profits. Okay. It must also be the case that some package that it's offered here in the middle must be, let's say that we pick this package here. We want to prove by contradiction that such a package does not exist. Okay. So let's assume that there exists a package P here that is preferred to the no insurance. So think of this as the no insurance outcome for both individuals. And we would like to make an argument that that cannot be an equilibrium. Okay, that therefore is going to some agent's going to have an incentive to unilaterally deviate there. And the way that we're going to do that is that we're effectively going to prove that by contradiction. So let's think about the safe individual. The safe individual has a lower probability of of an accident, and therefore the indifference curve of the safe individual will be steeper. Okay, at any such candidate point P. And the risky guy, let's do it in red, has a flatter indifference curve. Okay, has a flatter indifference curve. Now, I also need to be a bit careful here visually, because if I were to extend this green line, right, someone might argue, well, look, that point P will not be preferred. If I extend this green line, maybe that point P would not be preferred. So maybe, maybe I'll be a bit cheeky here and I'll do something like this. Okay, and say that, well, actually it is preferred. Okay, and it's clear that for the risky guy, right, that's at a higher indifference curve. That what would an indifference curve like this be? Okay, so that might seem like a possible equilibrium point, right? The insurance buyers have no incentive to unilaterally deviate if they have an option between no insurance and P. So they would pick P. The insurance firms are earning zero profits. So there is no incentive for a firm to enter and offer P again. Okay. But is there an incentive to enter and offer some alternative, let's say, let's call it P prime, that would make the insurance firms profits? And the answer to that is yes. So if I were to offer some P prime here, then you could see that it's below the current indifference curve of the risky type, so they would not want that. But it's above the green indifference curve of the safe type. Moreover, because it is below the actuarially fair line of the green type, that means that that P prime will only be taken by the safe individuals, and it would make the insurance firm a profit. We call that cream scheming. Okay, so this new entrant that's offering P prime is scheming all the good customers and is making a profit. And that is the proof by contradiction. Let's summarize. So the goal of this video was to show you that a pooling equilibrium cannot exist. In order to do that, we had to first come up with a definition of what does it mean to have two different types, a risky and a safe. We went for this idea of they look exactly the same. They could have the same utility function, and quite often they do, but they only differ in the probability of a loss. Well, that changes the indifference curve. Okay, at any given point, the indifference curve of the safe guy will be steeper and flatter for the risky guy. Then, because it has to be an equilibrium, and because we are assuming free entry and exit, it must be an outcome of the equilibrium, a feature of the equilibrium, that there is zero profit. And therefore, now we have infinitely many possibilities along the joint fair odds line. We picked a P, and then we were able to show that it doesn't matter where the P is, that equilibrium cannot be sustained because there would exist a P prime where firms would make profits. So that would be an argument that you would make for that a pooling equilibrium does not help, does not exist. I hope this helps. I'll see you on the next video where we'll likely cover the separating equilibrium.